We're going to start by multiplying two monomials or single terms together. And let me show you how this works. First thing to consider here is that x represents some number that we neither know nor care about. And what I would do here first is realize that within each of the monomials there's a multiplication sign itself. In other words, 4x squared means 4 times x squared. And 10x cubed means 10 times x cubed. So looking at this problem a little differently, we're really multiplying four things together. But two of them have exponents. X squared means x times itself, and x cubed means x times x times x. So what I would do next is take these two variables with exponents and expand them out. And what we can see here is that this is really a multiplication problem with 7 different factors in it, all strung out like this with multiplication signs in between. Well, one thing that we know about multiplication is that it's commutative, which means we can reverse the order without changing the result. So if I were to take the 4 and the 10 and put them in different places in the product, say at the beginning, this wouldn't have a different answer than the problem above it, and therefore this is an equivalent expression. The reason that I would want to put the numbers together and the x's together is because now I can simplify. As we know, 4 times 10 is 40, and x times x times x times x times x we don't know because we don't know what x is. But we do know that we have a shorthand notation that anything multiplied by itself 5 times can be written as that number to the power of 5. And once we've gotten this far, we don't need the times sign in the middle because writing 40x to the 5th means 40 times x to the 5th. And this is how you multiply monomials together. Now chances are you've learned this before from other teachers, and this work in between was probably never emphasized, although maybe it was, depending on your teacher. But there is a shortcut that you can use to not have to do all that writing. I wouldn't necessarily recommend the shortcut, but let's talk about it briefly. The shortcut that you've probably been told, and that some mathematicians use, is that when you're multiplying monomials, you can just multiply the coefficients together. The coefficients are the numbers in front of the variables. 4 times 10 is 40. You've probably also been told that you can add exponents. 2 plus 3 is 5. And while the shortcut of adding exponents isn't wrong by any means, it is a shortcut for the work that we just went through. My advice is to have yourself go through this work many, many times until you start to get a sense of how that shortcut works and when you can use it. Sometimes if we use shortcuts too soon in mathematics, then we start to mix up our shortcuts and use them in places where they don't belong. Here we're going to look at a different kind of multiplication problem where there are two terms in the second factor. The first thing worth pointing out here is that there's nothing between the 4x and the parentheses. And in algebra, when two things are placed next to each other without a plus, minus, times, or divide in between them, then it's always assumed that that's a multiplication. So I've put in the multiplication here. You don't have to write it, but it's good to think about it. Now, if I were going to follow the order of operations here, I would have to do what was in the parentheses first, or that's one thing I could do. But inside the parentheses, I have two terms that are not alike. One of them is an x, and one of them is an x squared. So there's no simplifying that I can do inside the parentheses. However, there is something I can do when multiplying these two terms by the outside factor, and that's the distributive property. In other words, I can take this factor of 4x and multiply it by each of the terms inside of the parentheses. That's the distributive property. By the way, the distributive property applies to addition and subtraction, but we sort of generically just write it with the plus, but it works on subtraction problems as well, as you can see here. Now, in order to continue simplifying, I have to keep in mind that there are some multiplication signs here that aren't shown. Each of these 4x's really means 4 times x, and the 3x means 3 times x, so I'll put that in as a reminder. Now you'll notice here I have many multiplications and a subtraction and an exponent. The one thing I can do with the exponent is I can write it out as x times itself. Remember, x is some number and we don't know what it is or care in this simplification exercise, but we do know that anything to the second power is that number times itself. And the benefit of writing out all the multiplications here is that we can now simplify this expression. Now remember, multiplication comes before subtraction, so I'll do the multiplications. There are three different things I can multiply here. The 3x's multiply together to make x cubed, the 2x's on the right multiply together to make x squared, and 4 times 3 is 12. Now I don't need the multiplication signs there. I could have them if I wanted, but I don't need them. I can simply write this expression, and now I've done the two multiplications. Now what would be last in the order of operations is subtraction. However, this subtraction can't be simplified because these two terms are not alike. One of them is an x cubed and one of them is an x squared. And if I can't perform this subtraction, then I've simplified this problem as far as I can, and that is the answer. Now this work that led me from problem to an equivalent expression is not always necessary to write it all out, but I do recommend that you start writing it out and get in the habit until you start to develop a sense for how the algebra works. There are students who can go straight from problem to equivalent expression here, and there's nothing wrong with that, but showing the work will train you into better habits and cause less mistakes in your future math. Now we're going to look at multiplying two polynomials together that have two terms each. These are called binomials. Let's think about the order of operations. We always start with what's inside the parentheses, but you'll notice inside these parentheses there are no terms that are alike in either pair that can be combined. So essentially there's nothing to do in the parentheses, and there's no exponents, which brings us to multiplication. Let's not forget when two things are put next to each other with no symbol in between them in algebra, that's a multiplication. I'll put the dot here just to be more clear about that. Now to multiply these, we're going to use the distributive property. Notice the multiplication there. We're going to use the distributive property by distributing the 2x minus 3 into the second set of parentheses. And once I've done that, I'm still in my multiplication step because I can now use the distributive property twice in each of these cases, which I've done here. But there's still more multiplication to do because each of these terms, most of them have a multiplication in them. So I'll work out each one of these separately, then that brings me down to here, and that ends my multiplication step. Now at this point, I'm down to the combining or the addition subtraction step. The only two terms that are combinable are the two in the middle because they're both x terms. And in order to combine those, you could factor out an x, then work out what's in the parentheses. That works out to 5. And now we're essentially done, other than I can rewrite x times 5 as 5 times x. And I'm now done multiplying these two polynomials. And this is a good strategy. It's a little bit lengthy, but it's a good strategy that emphasizes basic skills. Once you get good at this strategy, there's a shortcut that you can use where instead of showing all of that work, you would just show one step in between. It takes a little bit of a skill to get there, but I'll show it to you here and you can get a sense for how it works. You may have heard of it before. It's called FOIL. I'll tell you what these letters stand for and what we do in the FOIL process in just a minute. So what you do is you take the original problem, the binomial times the binomial, and you multiply the first term of each factor together. So 2x times x is 2x squared. After you've done that, you then multiply the outer terms together, which gives us 8x. This is in a little different order than we showed before, but it all works out the same. After the outer terms, you multiply the inner terms together, which gives me negative 3x. And finally, you multiply the last term of each binomial together and gives you the final term here. And once you've gone through this process, Notice it allows you to circumvent a lot of the work we saw earlier. You can simply combine any like terms, typically the middle two, and if you can combine those in your head without factoring out an x like we did before, you can see that that would be 5x, and that would lead me to my final answer, and that is the FOIL shortcut.